All right, I'm stopping my sharing. There you go. You're there, Brent.
Cool.
All right. Open up the chat so we can see. I think everyone is in here. All right. Like I said, my name's John Winchell from Eden, New York. Been with Alltech for 4 years. With this webinar series, I'm looking at doing a few different things, some practical things that I think a lot of people would like to hear and would like to see. At least I hope that we would like to see this. But today, my guest speaker is from north of the border, not far from Ottawa, Brent Corrigan. Brent's been with Alltech for a few years now, very well respected throughout the industry, a real wizard when it comes to rumen biology and great on the farm. And I really am very happy to have him here to talk about a kind of a topic that I think is a really good topic, and a topic that probably, I don't know if there's really been ever any webinars on manure screening / fecal starch, but Brent, you can take her over, and I am so proud and so happy to have you here. Thank you.
Sure. Thanks, John. Thanks for the invite. Really appreciate that. Yeah, so coming from here, from Eastern Ontario, a cool morning, still getting some freezing overnight. So definitely Fireside chat was, well, good name. So let's, we'll get started here. So just a little bit about myself. Grew up in a dairy farm, West Quebec. I went to chemical college and took dairy science. Graduated from with honors a dairy program. Started out as a farm consultant. Well, I'm back home for a few years trying dairy farming. That didn't work out, so I started as a farm consultant for a feed company in both that's in Quebec and Ontario. Did that for 14 years, balancing rations for feed, for dairy and beef, and doing crop supplies, managing a feed mill, looking after staff. And then after a while, after 14 years, I had a chance to manage the Canada Agriculture and Food Museum in Ottawa. There's a dairy barn there with a bunch of different types of animals. Was there for 5+ years as a farm operations manager, and then managing the staff and the equipment. And then after that, I had a chance to go work for CanWest DHI as a manager for Eastern Central Ontario. Sales and support for Dairy Comp. Really enjoyed that. Learned lots of things on a farm in terms of analytics. What are some of the numbers that make a dairy farm function? And then was able to start working with Alltech about 5+ years ago. Covered Eastern and Central Ontario and up into Huron Bay area, a bit in Northwestern Ontario. Also provide some dairy technical support for Quebec and BC on and off. So one of the things when I started 5 years ago with Alltech, we tried to figure out how our technologies work. So ended up putting together some rumen function audits, just looking at pen stage shakers, manure screens, trying to figure out how our technologies worked within a diet and a way of tracking them. So well, at that time, there wasn't a whole lot of information on manure screens. I had done them years ago, working for Prina. At that time, I was on the beta kind of testing group for Canada, trying to figure out what the numbers should be. Later on, after I moved away from Prina, they did come out with a set of numbers, and so they're still out there today. A lot of those numbers come back to 99, 2000, and hasn't really been a whole lot of updates on that. So we're just trying to figure out what kind of set of numbers worked, and then how everything tied together in terms of looking at the pen stage shaker box, so the front end of the cow, and then looking at the back end biology and seeing how that feed fermented. by doing the mirror screens. So everyone knows kind of 3 diets, what's on paper, what's prepared and fed the animal, and what's eaten. Kind of expand that a little bit, and I kind of like to look at what is actually fermented in a cow and what we hope is absorbed and utilized by that cow. And so I kind of think there's more like 5 diets. Just so many things where can change on the farm, where those first 3 points can go wrong. Farmers feed in pails, bales, and buckets, but we try to balance diets to 2 or 3 decimal places. But there's just a lot of noise on the farm. A lot of things change. For example, moistures on forages, particle size, mixing time, worn mixer knives, sorting. All these things can really alter the fermentation profile. Throw on top of that, you get some yeast, you get some molds, and then you could potentially have mycotoxins like penicilliums or T2, HT2, or fusaric acid that, again, alter how the feed ferments in the rumen. So we start out with lots of good intentions. We do the best we can for sampling, put together the diet we think will work, but again, all this noise, right? So, it's, we're going to talk here this morning about mirror screens, kind of why we do them. It's one of the quick things that really affect some of the diets. Again, is particle size and sorting. This one here looks like it's pretty decent diet, but the cows here in this example, we're really sorting this out because there's too much difference in particle size from the top 2 screens to the bottom 2. Other things we can have cows like this here, where you'll see in this quick video, these cows were really good at sorting. So here's just going to come up here in a second. You see this Jersey cow right here in front of you. She's a master sorter. This diet was really bulky, and we worked with a producer to try and get it smaller, particle size smaller, but she's a master sorter, leading to some of the issues on the farm. You also see other things too in terms of feed processing and mixing. Again, have about Warren knives. The time goes really quick in terms of, for farmers, in terms of when they change the knives. And if you really want to have a farmer have a funny look on a farmer's face, you just ask them when they last changed their knives. And it's really hard for them to remember. So as you can see here on the right, that's a picture of a new set of knives, a relatively new set of knives, and then the Warren knives here in the bottom. The thing to do, things can really happen here in terms of audits. We find out the audits. We can even find some broken knives or knives that have been taken out of the mixer for various reasons. And then you really get into things here on the right, like that mixing dead spots. If you look at this mixer video here, you'll see a spot on the bottom right of this TMR mixer where the feed is really not moving around at all. We're really getting some action on the left side of the mixer, but very little on the right side of the mixer, creating a dead spot. So again, all these 3 things, does a ration really match the model? And if not, well then how bad is it off, or what are some of the back-end biology going to tell us in terms of what we need to go back and fix in order so that the paper ration, or what the cow is actually fermenting, matches a paper ration or the computer model. But why do we track it, or why do I do manure screens and tracking it? A couple of reasons. One is, if there's a big milk drop, we want to check the back-end biology. We want to see, is the fermentation change or something has happened in the fermentation change? So we're looking like troubleshooting, looking for yeast, molds, mycotoxins, moisture changes, something that has changed on the dairy to go from a good diet to a drop in performance. The other thing too, we can do it the other way around, where we can go from low performance, figure out use a mirror screen tool to figure out what might be some of the things that might be affecting the diet, and then hopefully move that herd to a higher performance, or make the ration do what it's supposed to do. Working with the Master Feeds group here in Canada, created these audit forms. What's really neat about them is we're able to put in what the results were that day, both the shaker box and manure screen, and then we're kind of looking at the changes over time, whether it's better or worse, or what has changed in that time period. You know, farmers sometimes a little bit short on memory, or even ourselves. We really like we easily remember when we high performance. Love the high performance, but we also, you know, depending on if you're making a diet or if you're the farmer, if you're making the diet, you don't really want to remember about the low performance you had. Or if it's your farmer that's trying to pay bills, he will remember when that herd dropped, you know, how much they dropped, what the drop was. So again, we want to try and have even consistency going across, but we also want to be able to track what changes are happening in the farm. So just validates changing and feed processing, any feed technologies that was in there. And again, when things are going good, it also creates some customer value, and just showing the performance that the diet is doing. So I guess John has a question. Okay, so keep going. Oh, I guess John's going to stop here for a polling question, okay?
Yep, sorry about that.
Okay.
So this is similar to what we do with the Hordes Dairyman webinars that we see a lot. It's just a polling question. How often do you use the Cargill manure screening tool? We've got 18% of the voters in right now, so it's definitely a democracy at the moment, so we're doing pretty well. So we will end the polling here in probably a minute and then look at the results. All right, we're right at a minute, so we're 75% of the results in, so we will stop the poll here and we'll share the results. And what's your thoughts, Brent?
So it looks like 50% of the group says they're using manure screening as issues arise. Followed here by 19% and do not use it, and 15% quarterly. Yeah, so I would say that's pretty much what I'm seeing as well. Using when a problem arise, I would encourage consultants to use a little bit more than that. In terms of what I tend to use it is before I make a feed change, or before the feed advisor makes a feed change. Kind of want to see where things were at before we started or made that change, implement the change, and then 2 to 3 weeks later, even if production is going really well, kind of want to see what the new norm is. And or if you implemented the change and it didn't work out, then again, you come back in and do a manure screen to try and fine tune things before we start changing the diet or retweaking things. So all in all, that's good. So a little bit about manure screen procedures, kind of like, just like polling question, kind of try to do them different time points. Definitely do more of them in the fall and new feeds. Also, like I said, when diet changes, try to do them to look at changes over time, how things got better or worse, have you opened a new bunk, is it possible use for molds, I've changed it. Each time I try to correlate it back to the shaker box, so looking at, it helps to maybe identify some processing issues, correlated to the herd, does the manure screen results match what's happening in the herd? And then also, if a nutritionist put together a new diet, is there any way we can correlate the changes that was happening on the farm to an ROI or an income over feed cost? A little bit on the procedures. So this is kind of what I have figured out. This is not endorsed by Alltech. I don't have any written papers or anything like that on it. I use like a 2-quart plastic scoop. Comes with a big square scoop. I fill that full. So basically taking at least 10% of the herd, samples from the herd. Try not to take any extremes, so very loose manure, very tight manure, so I can get a herd average. And I'm doing a composite right across the herd, fresh cows, mid-lactation and late lactation cows. Especially, and then why I do that is because if the diet is for one group TMR, that kind of correlates to what's happening. Manure screen correlates to what's happening in that one group TMR diet. And I slowly flush the water through it into the screens. And in terms of total, when I'm done, I squeeze out the water, away each screen. And I know from that total, based on the sample size I started with, if I'm 450 grams or less of squeezed out material, I know that that's a very fast passage rate. Usually you'll see in the cows a looser manure, so just a lot more water going to the cow. Normally it runs at 500 to 600 grams, or if I'm 600 or plus, you just see a lot of excess fiber or grains in the manure screen, and that usually correlates to either higher fiber in the manure or firmer manure, or you can actually see some corn or other grains in the manure. Key thing is with manure screen is use a low water pressure. Otherwise, you could potentially force some of the particles or larger particle size into a smaller screen. When I do this composite herd sample, what I found here in Canada for our kind of diets, here in Ontario and into Quebec, you usually end up with 10 to 20% in the top screen, 25 to 35% in the middle screen, and 50 to 55% in the bottom screen. If you look at the Cargill manure screener, guideline was back in about 2000. They'll run slightly less in the top, very similar in the middle, and they'll be more like 60 to 62 or something like that on the bottom. So why it kind of seems to be is if you think back to 99, 2000, we were paid differently in components. Diets have changed over time. How feed gets processed. So a lot of things have changed since 2000. So I find that these numbers are a little more reflective of current situation in diets. Not to say they're right, but everybody will have their own different, may have a different set of numbers, but we find that, or I find when we get into these set of numbers here, the 10 to 20, the 25, 35, and 50 to 55, that when manure screen shows that things are really ticking along in the herd, got good production, good components, the MUNs are really good, the cows are really settled in and really working hard, and things seem to be just ticking along really well. So. Okay, so kind of to understand them, so I kind of come up with this chart. Basically, there's kind of like 4 types of scenarios. You can tie this back to IFM or fermentation models. Basically, we kind of have 4 types of diets, but fast and a slow. So I'll start with the top left one, number 1. So in fast fermentable diets where you have fast starch and a fast fiber. Essentially, kind of what you're going to see here is 2 scenarios. One is where you'd have a lot of fiber in the top of the screen, so 30% or more. Middle will be about the right range, or maybe on the lower end, and then your bottom will be less than the desired amount, so less than 50. And the reason being is just a lot of that unfermented feed is up in the top screen. So you'll see a lot of fiber in the manure. My guess is it's from more rumen pH fluctuations, you usually see reduced milk production. Components will usually bounce around. So if you're looking at butter fat, if it was a 4.2, you'll drop down to 4 or 3.97, back up to 4.1, 4.2. So really, really bouncy. And a lot of the times, these diets, if you remove some starch out of the diet, a lot of the times the milk goes up. So just when pushing a little bit, or they found that the fiber fermentability wasn't there. So the answer was to add more starch to the diet. They added starch, they got a bit of a response. They added a bit more starch, they got a bit of a response. They added even more again, and then things started going sideways. The other scenario here is where the top and middle screen are really good, and you just have a lot of material in the bottom, so 55% or more. These herds, where you'll see the manure will be quite variable, mostly on the loose side. You'll see some of the cows are actually pooling, or a lighter colored manure. Milk volume is really good, so this herd's really ticking right along. Butter fats maybe on the lower end. Locomotion score, you might see some cows are a little tender on the feet, or a little redness to the hairline. Sometimes the repro is really good, sometimes it's variable. Sometimes you'll see a really good herd health check, lots of pregnancies. The next one will be very few, and the next one will be pretty good again. These herds tend to have a pretty high other solids, lactose and other solids, so 5.95 to 6, and sometimes over 6. And biggest thing with these type herds is that if there are any slight changes in terms of digestibility and the forages or the grains, is where a lot of the wrecks happen. So here would be an example of a manure screen, higher in the top, kind of borderline to the middle, and then you not quite as much in the bottom. Here would be the second scenario of the first one. Would be the top was good, so fiber was broken down. You may see the odd corn kernel coming through from the corn silage, just because everything's fermenting really, really quick. Just doesn't hang around there very long. Middle is just in that range or slightly below, and then you just have a really heavy bottom. In this case here, these type of herds, again, the butter fat tends to get bouncy on these herds, and a lot of it's just that middle screen seems to be not as much in the middle screens. Everything's shifting to the bottom, so things are fermenting really, really fast. Second scenario on the fast side is you have a fast fiber, you have a slower starches, slow fermentable starches. This is where the herds you see a lot of the grain in manure. The grain processing could be better. So you'll have dry corn or high moisture corn that's not ground as fine as it should be, based on the fermentability of the fiber. And then a lot of the times if you do looking at fecal starch in these herds, they tend to be 5 or above. Here's a kind of the two scenarios of these type of herds, where you'll see again elevated fiber in the top. You'll be on the higher end in the middle, and then you'll be less than 50% on the bottom. These again, you see the whole grains in the top screen. A lot of times you see that drop in milk, or the peaks aren't what they should be. Variable components, either fat or protein, or sometimes the protein tends to be dropping down lower. Repro can be okay to poor, depending on herd management and other things. And then when you start to dig into it, try to solve the issue, a lot of times you have elevated fecal starch. These are the type of herds where you try to add more grain, the cows try to get a bit loose. You back off, things seem to go okay, you try to add a bit more grain, they get a bit loose. And you may or may not have some subclinical ketosis, or just a bit of an energy drain on the fresh cows that lead to those poor peaks. Second scenario is where it's really good on the top, it's borderline in the middle, and it's really, really heavy in the bottom. These are cows that are very manure, but mostly on the loose side, to the fast rate of passage. Again, you see a lot of pooling for these cows. milk volume is usually very good. These herds tend to have a lower butter fat. Again, locomotion score can be affected because they get a little sore in the feet, and then sometimes there's elevated fecal starch in these herds, but not always. So this would be type of, so the nurse screen here will be type. You see it's heavier in the top, very in the a little bit low in the middle, and then lower on the bottom. And these herds, you see that grain in manure, so you can see some grain, arrow to the grain in the top screen. You see some corn or some grains in the middle screen. You can see quite evident. And then even if you look at the bottom screen, you see some grain kernels in there. Traditionally, you shouldn't see any or have to look very, very hard to find grain kernels in the bottom screen if things are fermented properly. So the third scenario is a slow fermentable forages. So slow fiber where you have a medium to fast starch fermentability. Again, two scenarios with those ones. Basically, a lot with these are the ones we see elevated top, an elevated middle, and then a less than ideal bottom. Most of the time you see some large fiber pieces in the top screen. Herd usually drops in milk, has poor peaks. Tank butterfat tends to go up in these herds, and just because they have lower milk volume, so less dilution rate. The key that kind of shows that a lot of these herds is a lower other solids, so they end up being somewhere about 585 to 592. So again, the digestibility is just not there, and you're not releasing sugars and starches and faster fractions out of the diet and the fiber. And then most of the time, repro is usually okay. A lot of times it's just because there's less milk volume, right? So less peak strain on these cows, less energy going to milk, and then their repro usually shows up pretty good. So when you ask the farmer about repro, yeah, repro is good, but would like more milk. And then the last scenario of this one, third one, is where they're kind of a little bit on the higher end on the top, they're in the higher end in the middle, and then they're somewhere just under that 50 range in the bottom. These herds are usually the normal to firmer type manure. They're an average to lower milk volume, average to higher butterfat, and then repro is usually very good. A lot of times the milk production here, you're just running off the fast fractions of the diet. Things go along usually pretty good until so the farmer demands for more milk. And then because of the fiber is a slower fermentable fiber, the usual response is start putting more grain in the diet, and then things can go off the rails pretty quick. So this kind of scenario is where you see farmers milking a few extra cows. Life is usually pretty good as long as milk prices are good and grain prices are low. So this is kind of the ones where farmers don't usually make a whole lot of changes unless they're forced to. And then the last option one here is where you get a slow fermentable forages and slow fermentable starches. This one here is really the toughest one because it's a big time energy drain, and it's really a tough one for nutritionists to try and change. When you have both slow and slow, usually characterized by large fiber pieces in the top screen. Usually can sometimes see some grain in the manure. Manure is traditionally very firm to almost stacking up a bit, a couple inches. Low milk volume. Tank butterfats are usually up due to the lower milk volume. Sometimes you get lower milk proteins if just really not fermenting a whole lot of both fibers and starches. Over time, the proteins tend to get lower. They'll definitely have lower other solids. Repro can be anywhere from okay to terrible, just depending on the herd management, the barn, stocking density, insemination rates, things like that. And they tend to be just a high ration cost or a low income over feed costs. And then these herds definitely usually have elevated fecal starch. So nightmare for nutritionists, and these are the ones where really nobody is happy at the end of the day and really hard to fix. So moving along, so just a couple of fecal starch herd examples that I just kind of like to go over and kind of how that ties into the manure screen. So just one here, worked with last summer, where using Fermentrix, and farmer was kind of looking for a little better herd health on the front end or his early fresh cows, a little bit of subclinical ketosis. But things were ticking along pretty good. Looking at the right-hand side is the wet chemistry in the herd. So starch rate was on a higher end, but still good. So lots of starch in the diet. The key thing here is that the starch, or the CB1 rate, was slow. So 15. So it was a slow starch. Even though the fiber, the CB3 rate was pretty good. So this is just where they just didn't get a good match. So pulling the starch on this herd, we see that it's just pushing that upper 5 range. So based on some papers, and John will elaborate on a bit more, 3 to 5% is kind of the range you'd like to see. If within that range, you're usually okay. If you're 5 and above, there's definitely some opportunity there, a possible opportunity to change things around, try and get more energy out of the diet. So for this herd, we looked at, just because of there wasn't any other available starch sources we could switch to, using the farmer's on-farm grains. Couldn't process it anymore, so we looked at putting an enzyme in, a maize or alpha amylase enzyme in, to try and break down that cornstarch. Try to keep the diet as similar as possible, so kept your starch level about the same. So this is here is a Fermentrix after putting the enzyme in. The forage, though, did change slightly in this diet in the time put it in, and then took the sample. So the CB rate or the fiber level went up a little bit, so slightly more digestible forages. Added in the enzyme, actually pulled back on slightly on the quantity of corn going into the diet. And what this shows is kind of improved the CB1 rate. If you do the math using the microbial biomass from Fermentrix, that created a 2-liter potential. It was kind of hard to again, a lot of data noise, so it was hard to pull all the data, but somewhere about 1.5, 1.6 liters of milk, some of the fresher cows, and then we had the herd butterfat increase slightly. And then here would be, so then when we also at the same time we pulled the Fermentrix, or relatively the same time we pulled Fermentrix, we pulled the fecal starch sample, and we dropped it from that 5 down to 1.42. Probably a little bit too much, but again, we were trying to learn and understand about how using some enzymes. And the second herd was one in Central Ontario. Again, a slow 7-hour fermentability in the dry corn. Here's the manure screen before we started. So again, there's that elevated top screen, a little light in the middle, a little light on the bottom, and you can see the grains in the top, middle, and bottom screen. I did a Fermentrix first, or right after the manure screen, pulled a Fermentrix. Again, that CB1 rate was on the lower end, 15 versus 18 to 22. Starch rate on the right, there's about 22. Same thing with the diet. You try to put a bit more starch in the diet, cows will get a bit loose. You take it back out and things will be kind of back to normal. Manure was really firm and with lots of grain in the manure. Pulled a fecal starch, and it was actually 11% on this herd. So the farmer agreed to work with us on it. Put in the maize enzyme, and doing the math before and after, from 158 to 169, there was a potential there for about 2.4 liters of milk. We saw some increases on some of the earlier fresh cows. Some are about 1.5 to 1.8. Butterfat moved upwards. Again, this is summertime. We're doing this in July and early August. End of August. A lot of heat stress in this barn. Again, so it's hard to really pull a lot of data noise. Was it all to the enzymes? I wouldn't say it was, but definitely the farmer saw a change in manure consistency, less grain in the manure, and cows seem to handle the heat stress a little better. You can see here on the bottom left, the CB1 rate, we moved that CB1 rate up quite a bit from 15 to 26. Probably a little bit too much. So again, learning curve a bit on enzymes, but definitely big help. And then we pulled the sample for fecal starch after the fermentrix, and then we saw that fecal starch move from 11 down to 5.33, so back into that 3 to 5% range. So just to wrap up, some take-home messages on manure screens. Use it to evaluate ration fermentability. So as John says, back-end biology, identify other issues affecting the diet. Use it as a bigger picture approach on the dairy. It can lead to less time in reformulating a diet or doing these tweaks. Every time we do a tweak, we have to think about rumen bacteria, what it's going to do to them. So the least amount of tweaks we can do, sometimes the better, especially during summer heat stress. In terms of fecal starch testing, try to use it when I can. Use it to evaluate potential energy loss in the diet. Can also kind of use it to explain maybe why repro or milk isn't where it should be or where it should be balanced for. It's a great tool to talk to farmers about on-farm grain processing. And then from an Alltech perspective, we also try to use it to create some ROI on the enzyme technology. So that being said, that's what I have to present this morning. Hopefully I didn't ramble on too long, and then I'll open up to any questions from the group.
Well, Brent, I appreciate it. It was a wealth of knowledge. I need to start calling you Merlin. That was really great information. I know it was a little bit chewy because there's just so much information to it, and I appreciate it so much. I got a couple questions for you. Number one, why do you think people don't do manure screening that much in their normal herd visits? What's your opinion?
Well, it's not a lot of fun, first of all. It's not a very pleasant job, not a very clean job. Second of all, it does take time. So if you're looking after, 70 or 80 herds, or more, it definitely takes some time. The other part is it does take time to learn how to read them, like what you start doing them, what results you get, and how do you correlate that in. I've, over the past 5 years, done a lot of them, so you get it down pat pretty quick. But it is a bit daunting when you start. And then the third part is it's like, well, how do you tie that back into either the shaker box or the components or things on the herd? So it does take time to learn, but once you learn it, it really makes troubleshooting a lot faster. You a little bit more confidence in before you make those changes in the diet. It just gives you that extra confidence to know that the changes you're going to make are likely going to result in a better diet.
Well, that's a great answer, and I really appreciate that. A question that came in from Isabel out in Quebec. How does the Penn State compare to the manure screen? And are you able to see what is going on and how it correlates from the Penn State shaker box to the manure screen? Have you seen a lot of correlation?
Yep. So I'll back up to this slide here. So when I do the interpretation, farmers, most of them are very visual, A-type personalities. So kind of how it all ties together. And this is kind of very simple, but what I do is I just put tons of Penn State shaker boxes on the alley, do my manure screen, line them up in this fashion, and then just kind of tie it together here where the top two shaker boxes is, there's a relationship to the top of the manure screen. The middle is usually kind of more related to your intermediate section of the cow, or the rumen of the cow, and then your bottom of the manure screen is usually linked to more the liquid phase in the rumen of the cow. So just do the diagram: stomach, liquid, intermediate, fiber raft, lay them out on the floor, and then just look at particle size, and then what the results of the manure screen was, along with other visuals and other discussions we had in the farm.
All right, appreciate it. Well, that's a good answer. Another question coming in: should you screen manure at different times of the day, and how many hours after feed is delivered? What's your thoughts on that?
Mm-hmm. Yeah, what I tend to do, and maybe people will find differently, or people do it differently. So, example, if the farmer is feeding out usually about 6 o'clock in the morning, 5 to 6 in the morning, I try to do the manure screen somewhere either right before lunch or just after lunch. Some of it has to do with cow intakes, rate of passage, things like that. But basically, what I try to do is do it at the same time. If I'm looking at tracking the herd, I try to do it relatively the same time each time. I try to do the procedure the same way. So again, really kind of what you're doing is looking at changes over time. It's very important to try and do things the same way and roughly the same time, and then just again track that difference.
Kind of similar how we see MUN fluctuations depending on when the milk truck comes in or how close we were to when the cows were milked. That's interesting. Since we work for Alltech, couple quick things on that. What Alltech technology do you utilize to kind of change these manure screen numbers?
Yeah, so it depends on, again, whether we're looking at the different fractions of the diet. So looking at whether it's a fast fermentable diet or a slow fermentable diet. Kind of understand the diet first, and working with a feed advisor. So I'll go on the right side, so the slow fermentable forages. So kind of look at technologies, try and get that fiber to ferment better. So we look at things like live use, like USAC or USAC Farm Pack, things like Optogen, which is a time release nitrogen source. So looking at having different A fractions or breakdown of different A fractions within the diet. Again, we can look at enzymes, so a fiberzyme to break apart cellulase and xylanase, provided that the fiber is not too slow, so something we can work with. And then also be looking at the left side. If you can look at grain, if you can't get it processed any finer due to restrictions on the farm. Corn that has a higher vitreous starch, you might want to look at alpha amylase or amase technology there to try and break apart break apart the starch and release more of the sugars that's in the starch.
All right, appreciate it. Another question coming in from Mark out west. How about your manures collection technique? Do you need to pull basically off the cow or straight from the cow? Or do you pull from the floor? I think I know the answer to this, but I'd like to hear yours.
Yeah, it's an excellent question, Mark. So if it's a tie stall barn with straw and everything, of course, bedding, we'll try to get the cows up and pull, as the cow's getting up and goes to the bathroom, we'll try and get fresh samples before it goes mixed in with the bedding in the gutter. And try to get a cross section of the herd, fresh, mid lactation, later lactation. So working with the farmer on that as we're collecting samples. And then on a freestall, again, off the floor, but we got to be very careful of bedding. So I tend to take those samples, in up closer to the bunk, away from sand or shavings or straw that might be in the stall. Crossovers are a good place as well. You get away from all the bedding, and yeah, especially in the summertime, that's where you're going to get a good chunk of your samples.
Yeah, I would say with a lot of the fecal starch screening that I do as well, I usually try to follow around cows
Mm-hmm.
and try to go behind where the feed bunk is and just make sure I get as fresh a sample as I can from the cows with the least amount of contamination that's available. I have another question coming in from Roloff. Do you have recommendations on how to interpret Penn State results in a robot PMR ration versus a TMR? I mean, I know I have some information that I probably can share, and do you have some as well?
Yes. Created an audit form. It breaks it down whether it's a PMR or a TMR. And then I kind of split it again, whether it's a high performance or a high forage type diet. So the top, the shaker box, the top, and the bottom pan will change slightly depending on how the diet's set up. And then obviously with a robot herd, you're going to have less in the bottom pan versus the TMR.
All right, I appreciate it. Another question coming in. Do you find the results vary from a test done in October versus March and April historically?
On the manure screen?
Yes.
To some degree, yes, because you're looking at if it's in October where you're putting in unfermented or less fermented forages, assuming if they're tight for inventory, putting in less fermented forages, you're going to have more fiber, potentially more fiber in the top and middle screen. So it's going to show more on the slow fermentable side or slower fermentable side for fiber. Again, you're kind of asking other questions like other solids, butterfat, things like that. So yeah, there can be. Again, you have to kind of tie it into the bigger picture on the farm, ask lots of questions, and know whether it's fully fermented or short fermented.
And a question kind of for me that for looking on the nutrition side, we've run into this situation back in the last few years on feeding fresh corn silage and guys running into, tight on carryover, and they start to feed fresh corn silage right out of the gate. Do you see big changes in the manure screen typically from obviously well fermented corn silage to bouncing straight into fresh corn silage right out the gate?
Yeah, so fresh corn silage, if you're looking at the screen here, it's kind of, a lot of those will fall into the left side or the fast fermentable side, but usually in the bottom left quadrant, where rate of passage is quicker because of the available sugars, the less fermented fiber, and then sometimes you'll see some grain in the manure, some corn coming through, or what the pericarp, I guess, a lot to the corn silage. So you'll see a bit more grain coming through in the manure. And then, of course, being less fermented kind of does affect the rate of passage to some degree.
All right. No, I appreciate that. Yeah, I think I've seen that along the lines as well. We are getting close. It's 10:55, and I really don't want to go over 11 o'clock. So I'm going to unmute everyone and ask if there's any other questions.
No, Josh. I know to speak to him. I don't know where he came from or anything like that, but I don't know.
I might mute everybody back in. But if there are no other questions, I was going to talk a little bit about fecal starch, and I'll probably just hit on it very, very quickly. Let's see. Can you see my screen? I'm assuming so. Brent, can you see my screen okay?
Yes.
All right. I just want to touch base just a little bit on something that I've been doing here recently that seems to have helped, especially this year in the Northeast, working on fecal starch. I've been doing a lot more starch audits just because there's been such a variability in corn silage between farms in the different areas that I've been in. So I really started to look at it as you look at fecal starch and how the labs have tested for fecal starch and looking at the 7-hour starch numbers. And sometimes it works very well, and sometimes it really doesn't match up quite as well. So I've been doing this more with herds to kind of track the fecal starch and doing some things just a tad bit different than what other people have been looking at for this. Let's try to get my screen to advance here. Won't get it to advance. Let's see. This is kind of, like I said, the fecal starch that I'm doing. I took the name off the herd to protect the innocent, but what I like to do is I will run a fecal starch through from the lab, get the results back, and then I also like to take, this is a chart that I've put together looking at herd size, production, MUNs, fat, protein, other solids, corn silage processing score, and then if herds are using cornmeal, using the micron levels, and looking and testing the micron levels, and of course the fecal starch numbers just to see where we're at. I also tie this into IFM, which is a program that a test that Alltech runs, and we've run that quite a bit. Typically we run it on TMRs as a TMR evaluation. What it is if you put a TMR on rumen fluid and it's measured for 48 hours continuously, and you get the microbial biomass numbers, you get the fast pool numbers, and you get just a bunch of different numbers that show this. The TDMD is great for looking at the total energy potential or digestibility of the diet, but I've been using this a lot when it comes to corn silage in the diets. So you can see as you see that the graph down to the bottom left, you see that huge variation in starch B1, and then the graph to the right, that is the fast pool. And when you look at the fast pool, you see that graph, the trend line, which obviously as corn silage is fermenting, it's going to get better, which is nice to see how the IFM has been picking this up on the corn silage front. But then also look at the huge variation that I've been seeing throughout herds this season in both starch B1 and fast pool digestibility. And this really matches up very well on herds that are not milking quite as well, or herds that actually we've run into situations where as soon as they changed into a certain corn silage, the rails started to come off a little bit. Looking at this as well, the two graphs to the bottom are looking at that slow pool for corn silage, and then the graph to the right with the orange and blue lines is comparing BMRs to conventional corn silage. As you can see the differences where the IFM is picking that up as well. There is that one sample that is in the second graph to the right there that shows 86.9. That's a typo, but I left it in purposely because that's high moisture corn. So it just shows how this picks up on those different things. But going back to fecal starch, I take a look at the fecal starch samples, and then I put the different parameters in and measure what we're looking for. Obviously the goals are try to be under that 1 to 2% fecal starch. And one thing that I really like to say is each 1% increase in fecal starch is you're going to lose about 3/4 pound of milk. So a lot of times when you work with herds, and say especially this year where I've been seeing a lot of MUNs a little bit higher than they should be, passing corn just a little more than we should be, and milk production might be down 2, 3, 4, 5 pounds than what they're used to. A lot of times I'm starting to look at this fecal starch number and looking at IFMs, corn silage processing score, fecal starch, and then corn micron scores, just to make sure we're getting that coming out of the levels on what we're seeing in the farm. Because obviously we've all done rations, or a lot of us have done rations for years. But when you look at what's coming out of the cow, that really has nothing to do with the ration that we have on paper. So it's really important to look at the loss for that. This was also something that I look at when I take the fecal starch or the corn micron score samples and take a look at that so we can interpret that. This was a herd that was down about 5 pounds of milk. MUNs were up, fat test was up, protein was down, which most of us would look at it and say it's probably a fecal starch issue. But so we looked at processing score, that was okay. On the corn silage, the starch B1 actually was okay on the corn silage. But then when we finally, about a month later, they did finally take a micron test on this producer's corn, and we found out that their average particle size for their on-farm corn was 1159. Now, they were grinding their own corn, and I know I made the mistake when I he sent me the text and told me what the score was, and I sent him some information. I said, you need to fire that guy. And he's like, well, I'm the one that grinds it. So obviously he changed that quite a bit. And as soon as they changed that, manure got creamier, MUN started to drop, milk production came up, fat test came down. So it's really interesting how some of these tools that we work on really make a difference. And like I said, I'm happy to do these for any herds, or anybody, or any customers that you're working with. Like I said, I wanted to just rush through that real quick and see if we have any more here. But no other questions on that. And like I said, we're running right into that 11 o'clock hour. So I appreciate everyone's time and thank you. We had about almost 50 people on, or we had 50 people on for a while here. So it was really, really great information. And Brent, you always impress me, and I consider you a great friend and a great mentor. So thank you so much. I appreciate it.
Just learn from you, John.
Yeah, right. And we're going to probably continue to have these series as we come. Like I said, I would definitely love suggestions from you. I have an idea on about 5 or 6 ones that might be practical and good for everyone. But if you do have questions, just let me know. And again, thank you. We've recorded this, so hopefully the recording will come out well and everything will go good with it. But thank you so much for joining us on this Friday, and we appreciate your time, and thank you, and things will get better.